Thanks for joining today. I appreciate all y'all for rocking with me. Before we get into today's lesson, I need you to go ahead and hit that like button. And if you're not a subscriber yet, go ahead and subscribe to the channel and share with a homie of yours, a parent, whoever. Share with somebody. Now let's get into it. What's going on, everybody? My name is Dana Harris with Young Gurus Math Tutoring, and you know why I'm here, to drop some more math jewels. In this video, I'm talking about calculus, and we're going into the basic fundamentals of calculus, but we're going to talk about the constant rule of differentiation. Now, with the constant rule, we need to show what is the constant rule. What the constant rule says is, if I have the derivative, which is d of dx of c times f of x, right? Then that's equal to c times the derivative of x. All right? And we'll explain this. So the d dx is just standard notation for the derivative, one of the many notations for derivatives. C is just some constant, whatever number it is, and then f of x is the function. So if I have a constant, then you were taking the function, the constant times the derivative of that function. You want to see it in an example, so I'm going to give it to you. Example 1. Let's say if I want to find the derivative of y equals 2 over x. We'll start simple, okay? So I have the function y equals 2 over x. Now, the first thing I want to do is I want to rewrite this in exponent form. So I'm actually going to rewrite this as 2 times x to the negative 1 power, okay? So now, in this case, the constant c is the number 2. All right, so what we're going to say is the derivative of this is 2 times the derivative of x to the negative 1 power. So that d dx. All right, so I have my 2, and then I'm going to say times. Now, the derivative of x to the negative 1 power, we need to take this negative 1 right there, and then times x to the negative 1 minus 1 power. All right. If you're not familiar with this process, go back and look and watch my power rule video on derivatives. All right. So then now we just simplify from there, right? I have 2 times negative 1, which is negative 2, and then x to the negative 1 minus 1, which is x to the negative 2. So the derivative so d dx is going to equal, or actually we could write it like this. Let's just say f prime of x. So let's just say f prime of x equals negative 2x to the negative 2 power. And that's the derivative of this function 2 over x. Now we know this is equivalent, but one of the things we want to do actually is we want to get that back into exponent form. So I'm going to say actually negative 2 over x squared. I want to put it back in this form. So they're both the same, but I want to put it back in this form. So that's going to be that derivative. In this next video, we have a different function. So we have the function f of t, which is equal to 4t squared over 5. And we want to break this apart and find the derivative. So what I want to do is I'm going to rewrite this, right? So f prime of t is equal to 4/5 t squared. Now, in order to do this, we need to say basically, this is going to be 4/5 times the derivative, so d dt of t to the second power. All right, so all I did was I break apart the constant, which is c from the rule, and then times the derivative of the function t squared, right? So now here I'm going to say 4/5, all right? And then after I put the 4/5, I want to say 2, so times 2t to the 2 minus 1 power, all right? So then that gives me 4/5 times 2t squared. But we need, not t squared, but times 2t. But we need to simplify that because we got to multiply the 4/5 times the 2. All right, so that gives me 4/5 times 2 is 8/5 t, right? And when I have 8/5 t, that is basically the final derivative. So f prime of t is equal to 8/5 t. All right, that's your final derivative when we start off with 4t squared over 5. For the third example, I have another function. Once again, y equals 2 times the square root of x. First thing we want to do is we want to change this to exponent form. So let's say f prime of x, or we could say dx. Either notation is up to you. Of 2x to the 1/2 power. Okay, so this is our function, 2x to the 1/2 power. So what we have is we have 2 and then dx of x to the 1/2 power. Okay, now when I do this, we're actually going to say 2 and then times 1/2 x to the 1/2 minus 2/2. 2/2 is for the value of 1, all right? And then boom, I simply say 2 times 1/2 is 1, so I'm just going x to the negative 1/2, all right? So x to the negative 1/2, but I want to rewrite this in simplest form, so I'm just going to say simply 1 over the square root of x, all right? So f prime of x equals x to the negative 1/2, which is 1 over the square root of x. Final example, we're going to get down to the nitty gritty. All right, so I have y equals 1 over 2 times the cube root of x squared. The first thing you need to do in order to find this derivative is we want to rewrite it in exponent form. So this is actually, I'm going to say f of x equals, let's write it as 1/2, because the 1 over 2, and then we have x to the negative 2/3. Negative 2/3 because this exponent over that one, all right? So remember, the cube root is the 1/3 power, so, and then times 2, because if we multiply the exponents, 2 times 1/3 gives me 2/3, and it's negative because it's in the denominator. But let's get to the real stuff. So if I want to find the derivative of this, then I'm going to say 1/2 dx of x to the negative 2/3. All right, so here we go. We have 1/2 times, we take that negative 2/3, because you got to take, based on the power rule, we got to take this negative 2/3 to the front, and then times x to the negative 2/3 minus 3/3. Remember that 3/3 represents the 1. All right, so now let's simplify. 1/2 times negative 2/3 is going to actually be negative 1/3. And then I have x to the negative 5/3 power. All right, and then now I just want to simplify this. I'm simply going to simplify this, and let's write f prime of x here for the derivative. All right, so I'm going to simplify this, and it's actually going to be negative 1 over 3, and then x to the negative, oh, I'm sorry, not negative here because we're putting in the denominator, right? 5/3 power. All right, so once we write it like this, when we take this negative 5/3 to the denominator, it becomes a positive exponent. Thank you so much for watching. Make sure you like, share, and definitely subscribe. Young Gurus Math Tutoring. I got the solution to your math problems.